For over 100 years, Einstein's theory of relativity has been the absolute bedrock of modern physics. But what if I told you that its most famous effects, the bending of space, the slowing of time, what if all of that was just a grand illusion, an optical trick, kind of like looking at your reflection in a funhouse mirror? Today, we're diving into a really radical idea that challenges, well, just about everything we thought we knew. And this right here gets to the heart of the whole debate. On the left, you've got the classic Einstein model, where huge objects like planets and stars literally warp the fabric of spacetime itself. But the new theory on the right, it suggests something totally different. It says spacetime is actually flat, and it's our perception that gets warped, simply because of the time it takes for light and information to get to our eyes. Okay, so before we can really challenge the reigning champion, we gotta understand why it's the champion in the first place. So let's do a quick refresher on the standard picture of reality, according to Einstein. Right, so this is the physics you probably learned back in school. The idea that gravity isn't some invisible force pulling you down, but it's actually a curve in spacetime caused by mass and energy. Planets orbit the sun because they're just following the straightest path they can through this curved cosmic grid. It's a beautiful, elegant, and incredibly powerful idea. But what if we could show that you can get all those same weird relativistic effects without bending space-time at all? Well, that's the whole point of this clever little thought experiment. Let's call it the high-speed selfie. So picture this. You're zipping through space on a rocket, moving at a pretty significant chunk of the speed of light. You decide to hold out a mirror and a camera to snap a quick picture of yourself. Sounds simple enough, right? Well, at these speeds, things get very, very weird. Just look at the crazy path the light has to take here. Light from your face has to shoot forward to catch up with the moving mirror. Then it has to bounce off and travel back to catch up with your moving camera. And since the light from, say, your nose travels a slightly different distance than the light from your ear, every single ray of light is in its own little cosmic race, all trying to get to the camera lens. So if all these light rays are traveling different paths and taking different amounts of time to actually arrive at the camera, what happens when that shutter finally clicks? I mean, really think about it. What does the camera's sensor actually capture? Is it just a normal selfie, maybe a little blurry because you're moving fast? Or is it going to be something else entirely? The result is what the author of this whole theory calls a banana face. You see, the photograph isn't a snapshot of a single instant in time. Nope, it's a collage, a mosaic of different moments all patched together. The light from your nose might have left your face a nanosecond before the light from your ear, but they all arrived at the camera at the very same instant. So the photo captures this really distorted reality. And this right here, this brings us to the absolute core question. Standard relativity would say your face is actually physically distorting. But this new theory asks a different question. Is your face really changing shape, or are we just confusing a weird distorted photograph with the actual thing? So how do you solve this banana-faced paradox? Well, the author proposes a simple but really profound new rule for how light behaves, and it's the foundation for a whole new way of looking at reality. It's called the event anchor principle. And here's the gist. When an object emits a flash of light, the location of that flash gets anchored to a fixed point in space. The light wave then expands out from that origin point, just like ripples in a pond. But here's the crucial part. The expanding ripple is not dragged along with the moving object that made it. This analogy makes it super intuitive. Imagine you're on a moving train and you drop a pin out the window. The pin doesn't just fly alongside the train, right? Of course not. It hits the tracks and it stays exactly where you dropped it. The event anchor principle suggests light works the same way. The flash is pinned to the exact spot in space where it was created. Okay, let's walk through this step by step. Here we are at position A at time 0. A light inside the train flashes. Boom. That creates an event, a specific location in space and a specific moment in time where that light was born. Now, a moment later, the train has chugged along to position B, but notice the event, that origin point of the flash, it hasn't moved at all. It's still anchored to its original coordinates on the tracks, left behind by the train. So here's the punchline. As the train keeps going to position C, the light waves are expanding outwards, but they're expanding from the original, static location of the event. The light spreads out from where the train was, not from where the train is now. This one simple principle has huge implications. It forces us to draw a really sharp line between what is actually happening and what we are just observing. The classic distinction between the map and the territory. So this model breaks reality into 3 layers. First, there's the pure math. Then there's the territory. That's the actual physical universe as it really is, right now. And finally, there's the map. That's our observation of the universe, which is always built from delayed signals. It's always news from the past. So that banana face, it doesn't exist in the territory. It only exists on the map. And here is the entire argument in a single sentence. The thesis is that Einstein's theory made one fundamental mistake. It confused the strange properties of the delayed, distorted map with the actual properties of the physical territory. It basically mistook the photo for the face. So let's just put them side by side one last time to make it crystal clear. Standard relativity says space-time itself physically warps and changes, and that banana face distortion is a real physical effect happening to the object. This new model says, nope, space-time is stable, our perception is what's warped by signal lag, and the banana face is just an optical illusion. It's a powerful challenge, and it forces us to ask a really basic question. For 100 years, our physics has been based on analyzing the photograph. But what if we've been looking at it all wrong? What if the true nature of reality is far simpler, and we've just been fooled by the delay, by the cosmic post? It really makes you wonder, what else might just be a trick of the light?